Hi, welcome back to my channel. This is a presentation on what I call learning programming the hard way, or kind of a defense of precise programming. This is an accurate title. I'm not trying to do any clickbait here or plot twists. It's really about advocating for doing things the hard way. And again, this is kind of our informal mascot of the channel. This is the sea otter here. Sea otters will grab rocks from their environment and use them to crack open crabs and other types of shellfish. It's pretty dramatic when you see them do it. It's actually quite a bit of work. But at the end, they do get the best parts of the crab. So now this isn't like I'll work hard and things will come to you type of thing. There's don't work any harder than you have to. Always work smarter than harder. I'm all about that. But it's just the idea that basically there are sometimes advantages to doing things the hard way. But what is the hard way of learning a program? And I'm going to say we're going to think about it in terms of levels. And so I hope you'll forgive me on going on a bit of a digression, but we'll get back to the point. But I'm going to talk a little bit about the journey of how I see most programmers going through things in terms of how they engage with programming and where they end up. And obviously, the first level is that they're first exposed to the idea and they're learning the fundamentals of it. They learn about this thing called coding and they start learning about a language that they've learned. And at this point, now they're going to start getting used to the syntax tooling, basic building blocks of the language. And, they're going to learn more about the common phrases and idioms. It's kind of learning the basics of the language and how it goes on and how it works and really kind of playing with it. And at the second one, now what they're doing is that they're now more deliberately exploring stuff and there's intentionality there. And I kind of see it as like, well, I've read some books now, I've gotten seen the examples. Well, I want to actually write my little programs now. I want to write my own sentences and I want to write my own little paragraphs and so on and so forth. And so now these people are going to be exposed like, oh, making a small program from an abstract explanation makes sense for them. But they're going to be really using a lot of existing examples and modifications to those examples to achieve what they want to do. Level 3, as they get doing more and more of this, to get better at it, they'll start forming a mental model of what this programming language is, what programming is. And the reason that they'll do this is that they need to try to understand what a program does and why it does what it does. And the reason they do this is that more often than not, as people know, programs don't do what we think they're going to do, and we have to debug them. We have to figure out why they not work the way we want them to work. And because of this, learning about the debugging process, you need to have an understanding of like, well, if I don't understand what it's doing at all, sometimes I need to have a better understanding of this. So it's learning more about, okay, this is how these things work and how these fit together, and understanding this process of trying to get things to work the right way, versus, starts to build up this mental model and this mental model for formation. Um, what I think is interesting is that level 3 is where many problems arise, and this is where someone can actually have a big fork in the road in terms of their career or understanding of how to work with programming. And what it'll be is later on they will struggle with either incomplete or inaccurate models, or they'll have a real hard time incorporating new concepts into their smaller model there. And this is always going to happen. No one's going to be perfect in this phase. This is always going to be an issue. This struggle is kind of what learning is. But this is where a lot of people, will actually just fundamentally drop off. There's certain concepts that they just cannot incorporate. One of the things I saw when I was teaching or working with other students, one of the things that constantly kept people from either progressing or they kind of just glossed over it and they went on to something else. Recursion, it was probably the classic example of this. When they first introduced recursion, there's a lot of people that just could not fundamentally get it, and it just broke their brains. And eventually, they kind of had to learn how to tame it, or fake it and get around. Or sometimes the people just dropped out; they just got so confused and so overwhelmed by the stuff at that point. With algorithms, data structures, all the stuff that's going around them, that they decided that this wasn't the career for them. And that's certainly sad. But as you're going through this now and you're expanding the mental models, what you're going to do now is you're going to start bringing in context and you're going to start preparing for practical application. So if you're going to school, this is the time where you're going to oh, you know what? I'm getting ready to graduate. I don't want to do this as a career. And by the context here, you're going to start learning things about additional computational concepts from operating systems, compilers, CPU architecture, databases. I mean, there's so many things out there that you can bring into this type of thing. Web frameworks, UI design, all this stuff. But you're going to learn those types of concepts, and you're going to start seeing what kind of programming you want to do, and you're most kind of interested in, even though you're not specialized yet. Also, you're going to start hopefully working on tackling larger projects and working within teams as far as your software engineering courses. And I would actually say that one of the things I'm pretty passionate about in terms of education is the basically at some point, especially in the senior year, having basically a capstone project where people have to work in a larger team to achieve a certain goal. And my career fundamentally changed when I took that kind of class, and it was a new class at the time. It was developed. It was only like the first year that had been taught by this professor who had worked with HP. And basically, what it was using Visual Basic and other Windows technologies to control this Lego kind of the Mindstorms, first version of Mindstorms environment to do certain types of tasks. And basically, you had to build up the Legos parts of it. You had to have so there's a hardware component that had to interact with the software component that had to interact with this kind of stuff. And there's going to be two major teams. There's going to be a team A, a team B with sub teams within them. And because of how things worked out, a lot of the people that were like the kind of the standout academic types or really, had good grades kind of gravitated towards one team. And the people that were more middle of the road or actually, frankly, struggling with it, but still had, looking forward to graduate were on team B. And as you can imagine, the people that were on team B, overall, they annihilated us. And by me, us, I was on team A. I was one of those guys that had pretty good grades and was an individual contributor, quote unquote, just basically an individual that didn't contribute very well. And the team B people, because they had less egos and they also brought in people that basically weren't like these technical stars, but were actually technically through technical management was outstanding. And their ability to motivate people is really good, that they actually got stuff done. And the great thing about that class is that I saw a lot of people that thought, oh, maybe I can't do this, see an entire career path. And I'm sure a lot of them were incredibly successful moving out into the broader landscape because teamwork is important. And it's not always about just a raw technical skill. And that hit me so much that I actually changed my entire focus from kind of this low level operating systems, compilers focus to software engineering and how we could actually make better programmers out of more people. That we needed more diversity in the programming field and we needed more tools in our tool belt to teach people how to program. And that's kind of what motivated my career in UML and software engineering. And it's kind of why I'm doing this channel as well. So that theme is kind of stretched on throughout the rest of my computing career. So the thing about it is that more and more programmers nowadays are struggling to get to and feel comfortable at this level. And the reason is that there's just so much more context to absorb. There's much more pressure to perform out at this higher levels right away. You're already dealing with the myth of this, 10x coding, all this kind of other stuff. And, the job market, especially now at the time of filming, this is June 2025. The job market is particularly not great. There's some fundamental existential threats to how we view junior programmers, and there's lots of arguments on what's going on there. There's kind of I've never seen this much churn since maybe the collapse of the dot-com first dot-com economy. The thing about it is that I want to point out is that one has an excellent career by staying at or near level 4. And it's not just by gaining some technical skills, by gaining soft skills, by business knowledge, business communication, and improving your teamwork. You can you can do a very, very successful long-term career there. And that is not necessarily this path of becoming incredibly technically excellent. Now, I will talk about one more level. It is important, which is basically, you do see this, which is basically specialization and deep understanding, where someone goes into saying, hey, I'm gained enough experience to independently learn what they need to learn. So they're not necessarily going out to people to get coached or getting validation. They're actually be able to do that, gain understanding by going to their own resources and knowing how to find those things. They're also making deliberate choices of what areas they want to gain expertise on because they understand they can't learn everything about everything. So they are starting to get an idea of, oh, I really want to do this. I really like this part of programming. I don't like this part of programming. And so that's kind of the next level that some people go to. There is another level beyond that. I won't talk about that because basically very few people get there and very few people have an interest in that. So we will just leave that off for another day. The thing about this is that a lot of people think that they're that list level than they actually are at that level. One about it is they think that this level is what's necessary to be successful, and it's not. It's not only not is it needed, but it's not even sufficient. If you ever, whether even if you are at this level, doesn't necessarily mean you're going to have a successful career. You may have some fundamental other skills that are lacking, or you may have an expertise in something that's not in demand, and you're really passionate about it, and you don't want to do anything else, and so that could really impede your career. So being at level 5, in some sense, compared to other things like, for example, like say medicine, where a certain level of specialization is absolutely necessary. We need things like surgeons and dermatologists and so on and so forth. In computing, you can be very successful by being somewhat specialized, but not being deeply specialized or having this kind of deep I want to become an expert at something. And so when you're doing level of this stuff, it's really just extra credit. And so where this problem comes up is that when the people that think they have this understanding and they actually have a lot more misunderstandings, they don't understand it as well, they can propagate a lot of, well, basically they just cause a lot of problems and propagate a lot of misunderstanding and misinformation throughout an entire team, and can just turn entire teams or even organizations into just completely, dysfunctional places to work. And the best example of these people is that you cannot challenge them on anything, and they hate it as much as you're pointing out. Look, the emperor's not wearing clothes here. It's one of those things where, and certainly there's the people that are really successful learning doing that kind of thing. It's very important. But for example, it's one of those things where they hate someone pointing to them and saying, the solution that you're doing, this path you're going down to, very clearly isn't going to do what you're going to do for X, Y, and Z. Let's think about that. They will dig in and entrench and end up spending a lot of money that didn't need to be spent, and so on and so forth. Learning how to do those, organize those political shifts, is actually probably one of the hardest soft skills for a lot of people to learn. But those that do that and can become influencers or really change things, they can also have a very successful career. And that's one of those things where that's a specialization that isn't a technical one, but is a business specialization. And there's a lot of people that do that. They're level 5. They become managers, and very good managers. Now, given all this background, now I think I can start arguing about what I mean by learning things the hard way and why you should do that. And what I think the hard way is that we're adding a lot more rigor to the mental models of programming before the person goes off to practical application. And so when they're going from getting into level 3, looking at level 4, we add a lot more rigor there and really shore up that person's mental model before we let them go on to the next step. And I think that's one of those things where that is being eroded more quickly than ever. And that's why you're seeing these gaps in people being able to move from one thing to another. For example, when I graduated, it was kind of unthinkable that someone would be like, oh, well, I'm never going to have to learn another programming language. That was just a given. Of course, you're going to have to learn other programming languages and other libraries. That's just the nature of the beast. Where now you have people that insist, well, I'm a front-end developer in React. That's all I do. So I'll never write anything else but TypeScript, and I'll never ever use another framework but React, and that's it. And I'm not saying that isn't valid. There's plenty of people that make very good careers around that. But it's just that was a fundamental change. And the reason is that, again, there's so much more real world stuff, and there's pressures to make programmers even faster that kind of gets cut out. Also, there's one of those things where there's pressure to graduate more and more people into the field because of this. And so there's pressure on people that are academics or doing the types of things that are teaching to let people slide when those mental models aren't necessarily where you need them to be. And given the nature of the type of thing, there's certain types of things where, since this is not necessarily like mission critical, you can't do this with doctors, for example. If the doctor does not do certain types of things, they do not get to become doctors. And medical students and medical schools are very good about just basically making sure that not everybody actually gets out of their medical school. And they make a very good point about that. That basically, like, no one that graduates out of here is going to be incapable of being a doctor. But programmers, if you do a sloppy website on some random mobile app for some thing that doesn't really matter, it's hard to see the real world context and consequences, and because there's just not, it may not be as important as a lot of these other fields are. So about developing this mental model, it really comes down to what I see is that what we skip over is we don't let people really develop a model of what computation is and programming is outside the context of a computer. How to look at a program and abstractly reason about how it executes, right? And build that type of things up. And the reason being is that why would you bother when you can just literally make a change to a program and it instantly compiles and you just see it there? One of the classic examples I see of people that are when I can tell someone who's really stuck at a certain level of understanding when they become absolutely horrifically unable to work with anything that isn't like instant feedback. If I don't have reloading, this is the worst thing ever. If I don't make every single change doesn't instantly reflect on my web page or my program, I can't do anything. And the reason being is that they don't have any way to step back and say, oh, well, this is what's going on, and here's the 5 or 6 steps that I need to take to fix it, and then go on and then execute on that. That's being broken by that rapid cycle. When I was programming, that cycle was not possible. It was literally, you could not do it. You could not modify a C program and then just wait a second and then have it rerun again. The simplest of C programs took a few seconds, at least a few seconds, to link and do everything like that. And so you had no hope if you didn't stand back and think about what's actually going on here, getting back to the larger picture versus just kind of going back and forth on this really rapid iteration. Again, because those tools are available in certain environments, that makes perfect sense. But it does cut you off from a lot of other things. It's one of those things where if you're really used to that environment, you could never pivot to, like, say, embedded programming. Because embedded programming, you better get used to the idea that, well, okay, now you compiled this thing, and now it's going to take a while to flash it on your Raspberry Pi and see what happens. And so there's going to be these long cycles where you're going to have to go through and really work through these types of things and just not make changes over and over and over again. And what's more interesting thing about this is that one of the assertions I'm doing here is that having this mental model means that you're focusing on correctness first. And the reason being is that because it's abstract, you have to have an understanding, okay, this should do X, Y, and Z and stuff like that. It's not good enough to say, well, it magically passes a bunch of tests, it should work. You actually have to have this, oh, no, there's some concrete abstract way that this works outside of, well, here's these 20 cases that it does. Now, that doesn't necessarily mean that you can just do correctness and that's it. It's more and more likely you can do that kind of things. There's certain domains where that's less possible, but there's still a phase where you actually have to say, okay, well, what did I do? Does that actually work fast enough? And do I need to do optimization and stuff like that? And so that's a skill that you have to build up as well. But what I would argue now is that it is much more easy to optimize things that are correct versus possibly correct. And that's, I think, where I'll get a lot of people debate. It's like, no. Optimization is its own thing. And sometimes you have to make a lot of compromises to optimize things. And I think you actually have to make a lot less compromises in optimization, really, when you look things about it, when you kind of understand types of things where it's like, oh, no, wait a minute. This algorithm is good enough for that type of thing. But if you did it here, then that's really bad. Those kind of things. Now, programming the hard way, the other thing that's most interesting about it is that now, and this is where maybe I'll go on a little bit of a tangent, is that now more than ever, it contradicts others. But I will say this, I just want to make this very clear. These are perfectly valid ways of programming. But given the kind of cut-paste, example-based stuff, or prompt-based or LLM-based programming, which you're just kind of increasingly interacting with an LLM agent and having kind of a sense of what you how you prompt it, and what kind of things you feed it, and what you feed back to it, and just, or re-rolling the dice, as they say, starting over, seeing what it gets out, and kind of just learning that to massage a program into some shape. Um, Here, it's one of those things where you're now not looking at a rapid feedback cycle, not doing that. Um, and you're not taking full advantage of the fact that you can see that, what works right away and everything runs right away. But you're going back to saying, it's like, well, do I understand what this really is going on here? Do I do this? Do I fundamentally understand what's going on? When I am making a program and writing something, do I have a good abstract model of what's going on, why it works? Or am I just kind of blindly going through the motions? And my argument is that ultimately you're going to get in the weeds anyway. There's nothing I've seen in AI and the statistical prediction model that says that after a certain context window, things just don't go to heck in a handbasket. And the reason being is that these things are really, really large and take a lot of computational resources to train. And there's a lot of actually valid threats to AI as a whole in terms of, are they really just not wholesale violating copyright and just work on fundamentally plagiarizing every single thing on the internet for the profit of just a few companies? And, will that ultimately stand up to regulatory scrutiny? There's a question there. Not only that, but there's this collapse at a certain point where you can't get it to go any bigger without just spending way too much money for it to be practical. At some point, the humans actually, are very energy efficient and they have long careers. And not only that, but also the broader context of why you have an economy is, always fundamentally a question. And one of the things about it is that, if you're really trying to make it so that only a few people have all the wealth and less people have nothing and they don't have any jobs, that's not necessarily a sustainable way to have societies. And if you did a little bit of study back in the historical types of days, you can see that, when that happens, it usually doesn't end up being very pleasant for everybody involved, even the ones at the top. So the thing about it is that am passionate about this kind of stuff because I'm going to argue and push back against, like, you can use the shortcuts when you understand the road. And that's when you can say, it's like, okay, you know what? I don't want to deal with this. I'm going to see if I can feed it off to, Claude or Gemini or whatever, see if it gets me something that I can spit out. And that's fine because I know this is a one-off hack that I'm doing. I just don't want to make it any more deep than that. And I just don't want to learn about this stuff. And that's fine. But the thing about it is that you can't fundamentally do that when you're ultimately responsible for the result that's getting back and being put into a larger context. And I certainly understand it because a lot of programming is pretty repetitive. There's certain tasks that are very repetitive, and they're certainly not as interesting or as novel as we'd like to think. And it can be very easy to see why, if you're a programmer, say, well, my time's being wasted on this. Why am I doing this kind of stuff? I'll just hack it up. And the thing about that is that's doing yourself a disservice. And more often than not, given the nature of how people treat computing, it's giving the people behind you, doing them a great disservice. You're leaving behind messes that other people have to clean up. And that's just not sustainable. It's just not a good way to go about things. You can be really brilliant and move companies 3 or 4 years, and a lot of people made whole careers about that, and because they never ever had to go back and be accountable for the messes they make. No one ever calls up their future employers, because they're afraid of being liable for giving a bad reference. But basically, it's one of those things where it's like, they'll never go off and say, oh, by the way, this guy will do clever stuff for 2 years, but will leave nothing but a wake of just awful spaghetti code that you just all of a sudden now critically are relying on to working, and you can't get rid of, and now it's just a massive boat anchor for your company. And for all the people that are like, oh, this amazing startup, you don't see about the guy that goes from startup to startup and literally sinks them with the amount of technical debt that they accumulate because they think they're experts on things. It's really, really frustrating. And so what I would push back on fundamentally about that is that if you really do learn how to do things the hard way, then you just end up being better off, not only in your career, but there's certain things in your life that are just going to be easier. You're going to have things that you enjoy and more things that you can enjoy because you can do the thing like delayed gratification. You can be like, oh, you know what? I have to learn the skill. I just can't learn how to play guitar overnight. Oh, well, I'm going to start taking lessons and doing all that stuff. And then I can take satisfaction about, every hour I go do guitar lessons and I talk to people and I'm going to be in a band. all these great things come out of having to do some work. You don't get it for free. So if you're a programmer looking at this and from any level, um, and you were to ask me, well, what would you like, what would you think would be a good way of doing this if I want to learn more about programming languages? Well, I will give you the obviously biased take of, well, go check out my series on Racket, and knowing full well that I'm making the argument that you should take a programming language that's really not used in industry, outside some very, some dialects. Some people use Clojure, some people still use Lisp. That does happen. But you should learn this and learn it really deeply and understand it and spend a lot of time with it. And the reason being is that it strips away a lot of the, I would call, ceremony around what a programming language is. And not only that, but it has a lot of features for really fundamentally bending and changing the fundamental aspects of what a language is, and allows you to really write almost new languages within this environment to an extent that almost no other programming language allows you to do. And that kind of knowledge would be very, very useful. And so, and I would extend that to the educational type of things. I had to learn Scheme and had to do some work out of the Structure and Interpretation of Computer Programming textbook when I studied at an undergraduate. I would strongly suggest that every CS program turn itself into something that uses that curriculum more than it does now. I know that a lot of people they have built a lot around Python, and that's good. I think there's ways of using Python for that as well, but I think there's an amazing amount of value in having people really understand these fundamental concepts using this really focused programming language that will set them on a path to really being successful. And one of the reasons I say this is there's an irony here in that basically it's true that Racket itself or the Scheme is not very commonly used, but a very poorly understood, half-baked implementation of it with different syntax is now one of the most popular programming languages out there. And of course, I'm talking about JavaScript and TypeScript. And it's really one of those things where there's a lot of people's oh, well, we have to learn about this, this poorly done version of it with all these real world warts and hacks and types of stuff. And it's hard to say, well, we shouldn't have anybody learn the real elegant, simpler way of doing this before we do more complex languages. That you can't argue anymore. A lot of people, the argument back in the day was, well, we're learning Racket, but less and less people use Lisp. We know this, and everybody's doing C and C++, and no one's ever going to do functional programming, and that's never going to be a thing. And that was certainly true up until I got my was finishing up my PhD, and then all of a sudden, there's certain types of things that come around, more JavaScript. Microsoft starts doing this thing where they weren't too happy with that. Wow, Java's doing something, so they came up with this language called C# that started inhaling ideas from, Haskell, and, even to the point of making its own Haskell derivative F# as well, so they could steal ideas from those people. And all of a sudden, functional programming became the norm around this. And because I had studied, Racket and understood the fundamentals of what that was, I was able to adapt those types of patterns and use them without a problem. Didn't even think about it. It was just oh, actually, we're starting to use this again. That's great. And so, yeah. Basically, it's one of those things where this might end up being just a long advertisement for why Racket and the Racket programming environment. And not only that, but the textbooks around that are really excellent. Structure and Interpretation of Computer Programs, the second edition, is fabulous. I think anybody who gets through that is probably going to end up being more successful overall as a programmer, even than somebody who gets through the Art of Programming, which I would admit is more daunting, but in the modern environment is actually probably less applicable than understanding ideas behind functional programming languages and what languages really do in terms of modularity, state, and all this kind of stuff. How to Design Programs is an excellent fundamental text. I think that's a great one that gets overlooked a lot. I think that should be, mandatory for 2 semesters at any computer science program. So, but that's the end of my rant. And so, hopefully, at the end of the day, you can look back on this, and certainly, if you've watched this for the whole 30 minutes, thank you very much. You're probably more primed to doing things the hard way than others. and I really appreciate that. So please check out the rest of the videos on my channel. Also check out my racket programming videos. We're going to start up a whole series on macros. And the fun thing about that is I'm going to be learning along with you. I'm going to go dive in head first. And instead of just learning everything up front and spewing it out, when I know everything, we're going to get in the weeds together. And I think that should be an interesting set of videos. Anyway, thanks for watching. And subscribe, like, all that YouTube stuff. Thanks. Bye.